Hi there! Today we're going to be doing some data visualization, mapping anime titles according to the genres they belong to. Let's get right into it. The database that we'll be working from is MyAnimeList, one of the larger databases of anime information and user watch patterns on the internet. There was a data set collected in 2018 on Kaggle, which had around 300,000 users and 15,000 anime titles. The users will be filtered from 300,000 to 115,000 for users without metadata, and I'll be taking a sample of 1,500 TV shows out of around 4,600 total TV shows for the sake of my poor computer. If we look at the genre tags attached to these shows, we see that there's a great deal of multiplicity. The number of genre tags greatly exceeds the size of the sample because there are many genres associated with each tag. We can also see that the sample is fairly closely aligned with the overall data set in terms of the distribution of genre tags, and there are 40 total genres in the data set. So, if we want to measure genre similarity between shows, the first thing that we can look at is the number of shared genres. The second thing we can look at is to prioritize genres that are more rare, because shows that share rare genres are more likely to be similar. If we combine these two tendencies, we arrive at something that has already been tried, which is called term frequency inverse document frequency. We weight the genres by inverse log rarity to come up with genre vectors, and then we take the cosine similarity between them to arrive at a similarity score for each show pair. So once we get show pairs, we have nodes and edges that we can create networks from, and we're going to use force-directed graphs to do this. The three steps for creating a force-directed graph are: first, arrange the nodes randomly; second, apply forces simultaneously, attractive for nodes with edges between them and repelling for all nodes; and finally, we repeat this an arbitrary number of times with diminishing effect. We arrive at a map that looks like this: a number of blobs of varying size according to the number of people who have interacted with the show. Now, does this mean anything? If we look at an example genre, we can see that there is some degree of meaning created by this map. We can see the major genre concentrated to one side of the map, that subgenres occupy different areas within the major genre, and that subgenres are not necessarily cohesive, and the degree of cohesion can tell us something. For example, the shonen romance genre is fairly concentrated, whereas the shoujo romance genre is a little more scattered and has like one tomboy hanging out down here. And the seinen and josei romance genres are quite scattered around the edges of the dataset. Now, if we want to evaluate the mapping, some things we can look at are how robust it is and how accurate it is. So for robustness, we can take a look at what happens if we change the initial node randomization. Does the mapping look very different? And it turns out that it doesn't look that different, because we can take a rotation of the original map and arrive at something quite similar to the new one. Now, if we want to look at accuracy, one thing we can look at is how close are the most similar titles to each other. And it turns out that sometimes they're very close to each other, and we've probably done a good job, and sometimes they're quite far from each other, and that maybe there's room for improvement. But it's a little difficult to say overall how effective this is. Another thing we can look at is the relationship between the pairwise cosine similarity and the graph node distance. And we can see that there is a general decreasing trend, but perhaps not as strong as we might hope to see from a data set like this, using a method like this. So now that we've done this, what other things can we do with this data? Well, we have a first pass recommendation engine based on genre similarity, and we have the opportunity to integrate it with ratings and watch history. We can also take a look at viewer demographics and viewing profiles to create edges based on what shows have been watched together. We can try to investigate whether there is a better way to evaluate the quality of a genre map and determine, for example, whether this was actually an improvement over the initial estimate of just counting shared genres. And finally, we can take a look at how strong genre preferences are by seeing how much users' viewing profiles tend to vary from the average genre distribution, and investigate the existence of phenomena like genre trash. Thanks very much, and have a good day.